Welcome to 9th standard facilitator. In this video we are discussing about number system. Up to 8th standard you have already learned about natural numbers, whole numbers, integers and also rational numbers. Natural numbers are the counting numbers like 1, 2, 3, 4 and so on. If you take all the natural numbers and also 0, then those group of numbers are called as the whole numbers. Hence 0, 1, 2, 3, 4 and so on are called as whole numbers. If you take all the whole numbers and also negative numbers, then those group of numbers are called as integers. Hence integers are 0, plus or minus 1, plus or minus 2, plus or minus 3 and so on. If you take all the integers and also the fractions, those numbers are called as rational numbers. It means a number which can be written in the form of p by q, where p and q are integers and q not equal to 0, then those numbers are called as rational numbers. Hence, to call a number as a rational number, it must obey two conditions. Those are p and q. It means the numerator and the denominator should be integers, and also q not equal to 0. It means the denominator should not be equal to 0. Examples are 0, plus or minus 1 by 2, plus or minus 1, plus or minus 3 by 2, plus or minus 7 by 3, like this. See the note, 3 by 0 is not a rational number. Why? Because it obeys the first condition, that is p and q are integer. It means the numerator and denominators are integers, but it is not obeying the second condition. The second condition is the denominator should not be equal to 0. But here the denominator is 0. Hence this is not a rational number. See the second note, root 3 by 5 is not a rational number because it is not obeying the first condition. The numerator root 3 is not an integer. Hence root 3 by 5 is not a rational number. Now let us know about irrational numbers. A number which cannot be written in the form of p by q, where p and q are integers and q not equal to 0, then those numbers are called as irrational numbers. See the examples, root 3 by 2, root 5, root 7, root 2 by 5. Here the numerators are not an integer. Hence these are the irrational numbers. The reciprocals of these numbers are also irrational. The reciprocals like 2 by root 3, 1 by root 5, 1 by root 7, 5 by root 2 are also irrational because the denominators are non-integers. Note that root 4, root 9, root 16 are not the irrational numbers because root 4 value is 2, root 9 value is 3 and root 16 value is 4. These are the integers. Hence, these are not the irrational numbers. Let us see other definitions for rational and irrational numbers. Rational numbers. A number whose decimal expansion is terminating or non-terminating recurring is called a rational number. Here we have to know the meaning of the two words terminating and non-terminating recurring. Terminating means which ends. Recurring means which is repeating. It means if the decimal expansion of a number terminates, then it is called as rational, and also if the decimal expansion is non-terminating, it means it is not ending but it must have a repeating term, then it is called as a rational number. See the examples. In first and second examples, the decimal expansions are terminated. It means they ended. So those are called as the rational numbers. In third example, in the decimal expansion, 5 is repeating. It is indicating by the dots. In fourth example, 65 is repeating. It is indicating by dots. And also in fifth example, 278 is repeating. So third, fourth, fifth examples are having non-terminating recurring decimal expansions. Hence those are called as the rational numbers. Remember that non-terminating recurring means the number will not end but they will contain a repeating term. In third example, 5 is the repeating term. In fourth example, 65 is the repeating term. And in the fifth example, 278 is the repeating term. To indicate the repeating term, instead of putting the dots, we can put a bar on that repeating term. We can read it as 6.85 bar, 63.2365 bar, 8.278 bar. The bar indicates that the digits below the bar are the repeating terms. Remember that the repeating term may contain 1 digit or 2 digits or 3 digits. It may contain many number of digits. Now let us know about irrational numbers. A number whose decimal expansion is non-terminating, non-recurring is called as irrational number. First, know the meaning of the word non-terminating, non-recurring. Non-terminating means not ending. Non-recurring means not repeating. It means a number whose decimal expansion is not ending and not repeating. Then only it is called as an irrational number. See the examples. In first example, the decimal expansion is containing 10, 100, 1300, 1 4 times zeros. And it is continuing. Continuing means the pattern is continuing. What is the pattern? 1 0 is there, 1 00 is there, 1 000 is there. It means 0 is increasing. Someone may have doubt that 0 is the repeating term here, but here 0 is not the repeating term. See the pattern. You can easily understand that. See the example second. Here also there is no repeating term. And also in third and fourth also we cannot say it is having a repeating term. So those are the irrational numbers. Remember that here we have put the dots. It means the number is continuing, not ending. If we didn't put the dots, then it becomes rational number, because terminating expansion is nothing but rational number.